Good morning, honors chemistry students. This is Miss Rains with your second stoichiometric conversions video. This one we are using a slightly different resource. So I am actually taking my equations and I'm turning them into a map that will help guide me on all of my conversions. So if you don't like looking at just these equations, this particular strategy is very useful for many of my students. Now, the map actually came from the equations in themselves. So notice how I've got three things that are related to a mole. So these three things became part of my mole map. So my mass is my grams, my volume is my liter, and my particles is my particle. I use a very skeleton type mole map without the extra numbers, simply because I give you those numbers on your formula sheet. Plus, this is easier to write and draw as you're doing your practice problems or doing a test or a quiz. So the thing about the mole map is you do have to remember that this middle part, this mole ratio bridge, you must use your coefficients. Anytime you are crossing that mole ratio bridge, you've got to use your coefficients. So here's the way the map works. What you do is you read the problem and you determine what are you starting with, what are you going to, and it can be any two things in the substances. The left side of the map is whatever you start with. It's your arbitrarily A and your arbitrary B, but it can guide you up to setting up your conversions. You could have used this with one-step conversions that we've seen earlier in the year, but it kind of was, pointless because you're getting only one fraction. But the map has the same basic setup. The key to the map is picture this as literally lava or fire or something that you can't walk on or step on. I don't want green because it's definitely not grass. You've got to follow the paths. So the islands, the little circles and boxes, will let you know what you're putting where. And you're looking at the number of bridges to get from one location to another. So 3 bridges means 3 fractions. The key to the map is whatever you're getting rid of goes on bottom. For me, it's wherever I'm starting. My bottom part of my fraction is whatever you start on. Top of each fraction is whatever you're going to. And you're only allowed to move one step at a time. So the same steps that we saw earlier with doing the just normal conversions are still used here. The only difference is we're using our mole map to help kind of guide us in this particular process. So you'll notice that these examples are exactly the same as the previous ones. The only difference is I'm using my map. In fact, I'm going to actually end up skipping the second one just to make the video a little bit shorter. So find the map, determine what I'm starting with, what I'm going to. Remember, the left side of the map is arbitrarily my starting points. Right side of the map is my ending point. So NH3 is going to be on the left. And I am starting with grams. So that means I'm starting right here with mass, with a nice blue scribble. I'm ending with nitrogen, so that's my ending substance. And I'm ending with mass as well. So as I'm looking at my map, remember, we can't teleport from one island to the other. We don't have a spaceship or a TARDIS or something that allows us to travel between these things. So we have to follow the path. We follow our path and we can see that this is going to take 3 fractions to set up. The thing the map does not show you is that you have to write your starting number at the beginning. So my map, unfortunately, doesn't remind you that, hey, you've got to write what you start with at the very, very beginning, but it does let you know how to set it up. So the island I am on, I'm currently on the little squiggly part, I'm the little smiley face, has to go on bottom. That means mass of NH3 has to go on bottom, and mole goes on top. Mole of NH3 goes on top. I look at my equality statements and I can see that 1 mole equals molar mass. So remember earlier, I've got to find that number. So I've got 1 hydrogen, bad Miss Rains, 1 nitrogen plus 3 hydrogens get 17.04 grams of ammonia as its molar mass. So if you are doing this with the map, I encourage you draw it on a piece of paper, put a marker on it, use a coin or penny or something to mark your path, because we now have moved off of the first island and we are now a little smiley face on the second island. So wherever I'm on goes on bottom, whatever I'm going to goes on top. Whatever I'm on goes on bottom. So moles of NH3 have to go on bottom. Whatever I'm going to goes on top. Moles of N2 go on top. This is where I have to remember to look at my coefficients. So 1's going to go on top and 2 is going to go on bottom. So we filled in our second fraction. That means we can actually move our little marker. So I'm going to move my smiley face from the second island to the third island. Sad smiley face, but that's okay. So I am officially here and I'm trying to go to the house. I'm trying to get to my house so I know I'm exactly where I need to be. What I'm getting rid of goes on bottom. What I'm going to goes on top. So the island that I'm on goes on bottom. Moles of nitrogen have to go on bottom. Grams of nitrogen has to go on top. We know that 1 mole of nitrogen equals its molar mass. Nitrogen is N2, so it's not just 14, it is 28.02. So we use the islands to set up. My smiley face can now move from the last place to the house. I've actually gotten where I'm supposed to get, and that means that we have this conversion set up correctly. So it does not matter what I'm switching between. Any two substances in this map will work. Look at another example using our bridge, using our maps to help set up our problems. So looking at the words, I'm going to have to figure out what I'm starting with and what I'm going to. Since it has grams with the number, I know I'm starting with mass. So I'm starting here. And it's got liters of nitrogen. So some students ask me, well, Ms. Rains, how do you know which volume you're going to? Why are we not going to this volume? Well, liters does not have a number. Therefore, it's going to be my ending. It's what I am ending up, which means it's the right side of the map. The thing that has the number must be on the left side of the map. My map tells me that if I look at it, this is going to take 3 fractions, 3 conversions to set up. It lets me know that I'm going to need 3 steps, but that first thing my map doesn't tell me. I have to remember to write my given number and given unit. So I can see that I've got grams is my starting point, so it had to be the thing that went on the bottom of the fraction. I was going to moles. That was that first bridge that we crossed, so moles has to go on top. Looking at my next second fraction, so I've gotten rid of grams, so I'm now on this mole island. I'm on moles of NH3, and I've got to get some moles of nitrogen. So when I'm crossing this bridge, I know that I've got to look at my coefficients. So whatever I'm on goes on bottom. Whatever I'm going to goes on top. And my numbers come from my coefficients. So my ammonia and my nitrogen, my 1 and my 3. I filled in the second fraction so I can actually move my little marker. I'm no longer over here. I've now crossed the mole ratio bridge and I am now right here. I am working on trying to go from moles to volume, trying to go from moles to volume. So I can easily see that my last step, my last fraction, whatever I'm on, moles of nitrogen have to go on bottom, and the volume of nitrogen has to go on top. So my equations let me know that for volume, we're going to use 22.4 because nitrogen is a gas, and we're making the assumption that it is at STP, standard temperature and pressure. So I can actually see that my units cancel. Everything is set up. I've moved my marker my last place, and I am now actually at the house. So that means my equation is set up correctly. I can type it into the calculator, and the calculator gives me 31.8. I got to remember my significant figures. So I type and add an extra 0 to have that 4 significant figures. So making up a slightly different example. Hopefully my computer decides to cooperate with me. Using the same equation as above, let's determine the volume of NH3 needed to produce 68.4 liters of hydrogen. So what is the volume of ammonia needed to produce that many liters of hydrogen? Doesn't matter where the number is in the problem, it is what you're starting with. So I know that I'm starting with liters of hydrogen. I'm starting here with hydrogen, and I'm going to volume of ammonia. So even though it's not the reactant, the process is the same. So I can see that I can easily go straight across the map. Remember, we can't teleport, we can't jump. We literally have to follow the path. So this lets me know that it's going to take 3 conversions. The one thing the map doesn't tell me is that I got to write that given number at the very beginning, 68.4 liters of H2. So I've got to move from liters to moles. Liters goes on bottom, moles goes on top. My cheat sheet tells me that 1 mole equals 22.4 liters. Remember, these numbers come from your cheat sheet. So you've moved from the first box to the second. I'm now on the next island, and I'm trying to cross the second bridge. So I'm trying to set it up, and I can see that I am currently on moles of hydrogen. So it has to go on bottom. And I'm trying to go to moles of ammonia. I'm trying to get to my ending substance. Remember, it's not a product. It's just whatever it's asking for at the end. So I look at my coefficients because it's a mole and a mole. And my coefficients in this case are 2 and 3. So 3 is with the hydrogen, it goes on bottom. 2 is with the nitrogen, it goes on top. So we can move our marker across the second bridge as we are now setting up the third fraction. So now I can see that I'm trying to go from moles to volume. So this last fraction, I can see that I'm trying to get rid of moles of NH3, and I'm trying to go to liters of NH3. So that relationship again, 1 mole equals 22.4 liters. So handy dandy calculator, I type this in. Some students are like, but Miss Rains, notice your first fraction and your last fraction are the same. Well, in terms of numbers, yes, they are mathematically the same. But when you take a moment and you look at the units are not the same. Therefore, these fractions are not identical. We are switching substances and units on those first and last steps. I want to show this whole process so that we can actually show what is going on with the units and the numbers. This is science. This isn't just math. We've got to use math with a purpose. So handy dandy calculator gives me 45.6 exactly. Significant figures. I look at it and I can see that I started with 3 numbers, so I'm going to end with 3 numbers. Give it its unit and its chemical formula. So that is using the mole map. We've set up our third fraction, and we've made it to our ending point. We've made it to where we want to be. So I know that this particular conversion is set up completely correct. I hope this helps. If you need some more assistance, if you need it broken down a little bit more, or just want to verify that you are setting it up correctly, feel free to hop into one of the virtual class settings or send me a message letting me know that you need to schedule another time. See you guys, and hope you have a nice day.